Section 6.2 goes through the properties of rational exponents. Now we did this quickly yesterday, but rational exponents are exponents that have a fraction. What's really cool about this section is that it uses all of the properties you've already seen before. You guys will be making a foldable with this, and I'll let you use that on the test, so it's good. However, you have seen this before. Our first property is what we use when we have two bases that are the same and different exponents, and we're multiplying. So for example, if we have 5 to the 1/2 power times 5 to the 3/2 power, my property tells me I'm going to add those exponents. So I would go 5 to the 1/2 plus 3/2 power. When I simplify that, 1/2 plus 3/2 gives me 4/2, which is just 2. And I know 5 squared is 25. My next property is what I use if I have one base and two exponents. This is my power to a power property. This property tells me to multiply them. So if I have 3 to the 5/2 power raised to the second power, I'm going to go 3. I'm going to take 5/2 and multiply by 2. 5/2 times 2 is the same as 3 to the 10 over 2, which is 3 to the 5th power, which gives me 243. Remember guys, we're using our rules of fractions. So if I'm multiplying 5/2 times 2, I make that 2 over 1. I multiply straight across the top, straight across the bottom. If you use your calculator, don't forget to put parentheses around each fraction as you do these properties. My last property on this slide tells me that if I have two different bases, now this could be in the form of two numbers, it could be a number and a variable, or two variables. It says that if I'm raising that whole thing to one exponent, I have to distribute that exponent to each term inside the variable, inside the parentheses. So if I have 4xy raised to the 5/2 power, I would take that 5/2 to 4, and that doesn't simplify very nicely, so we're just going to, actually, that one does simplify nicely, which we talked about today, and we'll do that in a second. We would take that to the x and to the y. Now remember, today we talked about how to simplify 4 to the 5/2. The bottom tells me what root I'm doing. So this is a 2, so that means the square root of 4, and then it wants me to raise it to the 5th power. So I'm going to go 2 to the 5th power, which gives me 32. Again, you guys will be using these properties a lot, so I will have you make a foldable with it. We have 3 more properties to go through. If we have a negative exponent, that moves to the bottom. So here we have 36 to the negative 1/2. That becomes 1 over 36 to the positive 1/2 when it moves to the bottom, or it goes over 1. So right now this is 36 to the negative 1/2. I can always put that over 1, any whole number like that. I actually flip that fraction to make it positive, and then I know that 36 to the 1/2 power is the same as the square root of 36, which is 6. This next one here is the quotient property. If we have the same base but different exponents, I'm going to subtract my exponents, the top minus the bottom. Same basis here, so we're going to subtract our exponents. We're going to go 4 to the 5 halves minus 1 half. Always start with the top. Then if you end up with a negative, you can either flip it or leave it where it is. So this leaves me 5 halves minus 1 half is 4 halves, which is just 2. And I know that 4 squared is 16. My last property says if I am dividing, if I have a fraction raised to an exponent, I'm going to distribute that exponent to the top and to the bottom. 27 over 64 to the 1/3 power is the same, according to my property. I would distribute that exponent. 27 to the 1/3 over 64 to the 1/3, which is just 3/4. These properties are in your book if you want to see them on paper. Otherwise, feel free to watch this again tonight. Now these two properties are also going to go in your foldable. We have the product property of radicals. It's the same as your square root radicals. Our square root radicals told us that if we are multiplying two radicals, doesn't matter what is underneath that radical, we just multiply the numbers. Same deal with these nth root. Okay? Same with the quotient. If we're taking the nth root of a fraction, we take the nth root of the top divided by the nth root of the bottom. These properties are the same as your other radicals that you guys did in section 4.5. The only difference is they have a number with them. So we'll use slightly different numbers to evaluate it, but exactly the same way. So for A, I have cube root of 12 times the cube root of 18. Same radical, so that means I can just multiply my numbers. 12 times 18 gives me 216, and I can take 216 and raise it to the 1/3 power in my calculator to find out that gives me 6. Now for the bottom one here, we're taking the 4th root of the top divided by the 4th root of the bottom. I don't want to evaluate that right as it is because taking the 4th root of 5 would give me a decimal, and we don't want to deal with that anymore. So we are going to use the reverse of this quotient property. We're going to say if I'm taking the 4th root of the top and the bottom, that I can almost factor out that 4th root and say I'm just going to divide 80 and 5. 80 divided by 5 gives me 16. And 16, I can take the 4th root of very nicely by going 16 to the 1/4 power in my calculator, and I get 2. Actually, we did talk about today how you would actually get plus or minus 2. Now we want to talk about writing radicals in simplest form. Same process as writing your square root radicals in simplest form. These just use different perfect squares, but again, same math you're going to do. So for A, we want to rewrite the cube root of 135 into simplest form. Taking 135 and raising it to the 1/3 power would give us a decimal. So what we're going to do, like we did before, is